So batteries. Batteries are voltaic cells. And what we've been talking about are voltaic cells or galvanic cells. Those are the types of electrochemical cells that produce electricity spontaneously. The reactions occur spontaneously. So a battery is just a voltaic cell that's conveniently packaged. So it's not going to slosh all over the place or fall apart, and you can stick it in your device and take it with you. The actual reaction that's occurring in that battery depends on the type of battery. So we're going to have a brief overview of lots of different kinds of batteries today. So one of the original batteries was a dry cell battery, called dry cell because it does not contain large amounts of water. Stupid thing. So here we have zinc being oxidized and manganese dioxide being reduced. Here we have a schematic of the battery. Instead of the pictures we've had of the two different beakers with a salt bridge and everything, what we've got here is we've got a zinc case on the outside that's containing the whole thing, and that's actually acting as the anode. And then there's a graphite rod in the center that's the cathode, and then we've got this paste. So it's not a liquid, but it's got water in it, and so things can move, ions can move. And so the reaction is occurring in here. So these are the two half reactions. So let's just add those together and see what the overall reaction is. So these are all set up so that we've got our electrons equal in number. And then we can look for other common ions, but there aren't any. So we've got zinc, metal, and manganese 2 oxide, and ammonium ion. And those react to form, this is what you do when your long equation doesn't fit on the line. Mn2O3 solid plus ammonia gas and water. So the combination of these two half reactions produce a voltage of about 1.5 volts. Any questions? Alkaline batteries. You're probably familiar with these. These are a type of dry cell, but the half reactions are occurring in a basic medium. That's why they're called alkaline, because they're basic. So here we've got zinc again and the manganese 2 oxide, but in a basic environment, then the reaction's a little different. Let's just go ahead and finish that guy off. So again, there's 2 electrons. Here we have hydroxide in the oxidation reaction and hydroxide in the reduction reaction being used in one, produced in the other, and so we can cross those out as well. So zinc plus 2 MnO2 plus 2 H2O forming zinc hydroxide this time, plus this funny guy. Oops. Yeah, that's the end of it. So this has the same basic setup as the dry cell. You've got a graphite cathode in the center, a zinc casing that acts as the anode, and then you've got a paste in here, MnO2 in potassium hydroxide. You've got, some other little details in there, but that's the idea of an alkaline battery. Now, have you ever seen an alkaline battery that's like starting to come apart and there's crusty stuff? Do you want to get that on your skin? No, because it's probably containing a lot of sodium hydroxide or potassium hydroxide, and that's just bad news. So pick it up with a paper towel or something and dispose of that right away. Okay, a lead acid storage battery. Okay, so here's a picture of one of these. Where do you see these? Under the hood of your car. So this is what a typical car battery is. It actually consists of 6 separate cells that are wired together, because the car battery produces 12 volts. But you can't find any combination of half reactions that's going to give you 12 volts. So what you do is you put several of them in series, and then the potentials add together. So each cell is producing 2 volts, and there's 6 of them, so you get a total of 12 volts. So it's a lead acid storage battery because it uses lead and acid. Crazy, that name. Okay, let's look at this overall reaction. So 2 electrons. Oh, there's a missing plus sign. That's okay. There's 1 hydrogen ion there, so we can get rid of that and just have 2 over here. That looks like all of the spectators. So then we've got lead, and we've got actually 2 hydrogen sulfate ions there, 1 participating in each half reaction, and lead oxide, lead 2 oxide. And that's going to form a total of 3 moles of lead sulfate, lead 2 sulfate, and water. So these batteries are not dry cells. They do have solution in them. And so some of the older batteries, you actually had to check the water level and add water occasionally. The newer ones are sealed, and you're not supposed to have to do that. So both of these electrodes are producing solid lead sulfate. And so if the battery runs for too long, that's going to coat the outside of the electrodes and act as an insulator, and then it won't run anymore. And so what happens is you recharge the battery using an external current, and then we're doing electrolysis, and we'll talk about that in the next section. You're running these reactions backward, and so then you get all of that lead sulfate back off of the electrodes. And this is another battery that, you know, if that should open up, you want to be really careful with the contents in there because they will do a number on your skin. So that lead acid storage battery is rechargeable. In your car, you have an alternator which uses energy from the gasoline engine to recharge the battery, so the next time you need to start the car, it's ready to go, provided everything's working right? So there are other rechargeable batteries. Nickel-cadmium batteries, also called NiCad. These are fairly common. The anode is solid cadmium, which gets oxidized to cadmium hydroxide. The cathode is this odd-looking substance. It's a nickel with an oxide and a hydroxide ion, and that gets reduced to nickel hydroxide. Overall, the reaction is going to produce 1.3 volts. Like in the lead acid storage battery, we get these solid products building up on the electrodes, but then if we use an external source to run current through it in the opposite direction, we can regenerate the reactants and it'll be ready to go again. The bad thing about recharging these is you need to be careful not to overcharge them, because if you run them in reverse past the point where you've regenerated the starting materials, you can have unwanted side reactions occurring. And so a good battery charger will have a sensor that tells it when you're done recharging your battery and will shut off the current. Otherwise, you can wreck the battery. Yes?
So if the lead acid battery is a rechargeable battery, then why is it that, this might be a dumb question, but why is it that you need to replace it so often?
That's an excellent question. So this is rechargeable. Why do we have to keep replacing them? Because typically a car battery will last 3 years or 5 years, depending on how much money you spend on it. So it is being recharged every time you drive your car. But eventually, it's not going to work anymore because things aren't perfect, basically. Stuff happens. So in a perfect world, if everything went as we desired, you could recharge this thing indefinitely. But it doesn't work that way.
Is it because like there's outside, components affecting?
I think it's just a breakdown in what's inside the battery itself.
Could it be free from could it also be from overcharging?
It could be from overcharging, but it's a little bit like the laws of thermodynamics, right? You can't get a free lunch, and you can't even break even on stuff. So every time you charge and recharge, it's not going to be perfect. And so eventually it's not going to work well anymore. That's not a very good, satisfying answer, but it's the best I can do. And that happens with these other rechargeable batteries too. They wear out after a while, right? You may have noticed that with your cell phone. When it was brand new, the battery lasted a long time. And as it gets older, the battery just doesn't last as long as it used to. Nickel cadmium. Cadmium is a heavy metal, and it's toxic. So trying to find alternatives to that, nickel metal hydride, well, abbreviated NIMH for metal hydride, has the same cathode reaction. The anode reaction is different. It's a metal alloy with hydrogen atoms in it, and it's the hydrogen atoms that get oxidized. This has greater energy density than a NiCad battery. And by that we mean how much energy can you get out of the battery per unit of battery mass. So a lead acid storage battery, hopefully you know that lead is a very dense metal, right? It's very heavy. And so those batteries, if you've ever changed one, those things are really heavy, right? So it's not great to have a heavy battery because in your car, you're moving the car and you're also having to move the battery, right? That's why you don't want to store loads of bricks in your trunk and just drive around all the time with them, right? Cuts down on your mileage. So if you can have a lighter battery, then that's a good thing. It's more efficient, right? So these nickel metal hydride batteries don't weigh as much, and so they've got better, larger energy density. So that's a good thing. And then there's lithium ion batteries. These are also rechargeable. These are the newest type of battery. They're also the most expensive. These are common in cell phones, laptops, digital cameras, etc. They have even higher energy density. I mean, I got this computer here, and this thing will run literally almost all day long, as long as you're not doing anything crazy on it. And yet it's very small and it's very light. It's got a lithium ion battery in it, so it doesn't take up a lot of space and it's not very heavy. These batteries work differently than the other batteries we've looked at, so we're not going to go into too much detail here. But what we've got going on is a graphite anode, and the cathode is a lithium transition metal oxide. And we've got lithium ions that are actually moving from the anode to the cathode. So that's a bit different than the other types of batteries. Yeah, question?
Are we going to charge on like all the different types of batteries?
That's an excellent question. So am I going to test you to see about your extensive knowledge of batteries? Like, what's the half reactions for a nickel cadmium battery? No, I'm not going to do that. I think it's good to have some general knowledge, maybe things like, well, you can damage a battery by overcharging it. Some batteries can't be recharged. The ideas of toxicity and energy density, which ones give you better energy density than the others, those sorts of things. General understanding of how a battery works, but no, I'm not going to test you on details because I can't remember them myself. So those are batteries, and then there are fuel cells. So in a battery, you have reactants, and as the reactants react, they produce electricity in the products, and then it stops working. So you can recharge it, but you don't actually open it up and put anything in there. A fuel cell is a chemical reaction producing electricity again, but here you're not charging and recharging, you're actually just putting fuel into it. It's generating electricity, and you don't recharge it, you just put more fuel in. So the hydrogen-oxygen fuel cell is the most common, and the way this works is you've got hydrogen gas flowing past the anode, which is a screen that has a platinum catalyst on it. So the hydrogen gas is oxidized. Oxygen gas flows past the cathode and is reduced, and both of those reactions are going to produce water. So this is great. We've got hydrogen gas, oxygen gas, we put them together, we get electricity, and we produce water. I mean, what's not to love about that? The problem is, where do you get the hydrogen? And you need the oxygen too. I mean, there's some oxygen in the air, so that's good, but you got to have the hydrogen. So the stumbling block here is the source of hydrogen. So they're not really practical yet because you can't just go fill up your car with hydrogen gas at the station, right? Another issue is that you don't want those gases to mix because they're kind of explosive. Yeah. But these sorts of fuel cells have been used in, I believe, on the space shuttle. And so you're generating electricity, and then you're also making pure water, and so then the astronauts can actually drink the water. Right? Cool. So where do we get, well, here's a picture of the fuel cell. So we've got hydrogen gas coming in here, going past the anode, being oxidized. We've got oxygen gas coming in here and being reduced at the cathode. And so the hydroxide and the hydrogen come together to make water.